Hi folks, so this is the 2022 Leaving Cert Ordinary Paper 1, and we're going to start with question 1 obviously. So the question 1 is complex numbers. So the first question, it's nice enough. You just have to write down the values of Z1 and it's Z1 conjugate there. We'll come to that in a minute. Let's look at Z1 first. So Z1 you can see is down here on the graph. So you always go across first and then up or down. So you go left or right and then up and down. So if we start in the middle there, the kind of the origin, you have to go across to -2. So I'm going to put in -2. And then you have to go down to -3. So it'll be -3. And then that's the imaginary part. So you have to put an I on it. So -2 -3i. So that's the answer to that. Second one then is the conjugate of, so the little line across the top of there. So you'll see there, it's Z1 with a little line across the top. The little line across the top means conjugate. So you have to remember what that is. And really all it is, it's very, very simple. You just have to change the sign of the imaginary part. So of the -3i. So that would become a +3i. So most of the time, it's just going to be a matter of changing the sign that's in the middle. Okay, so -2 -3i is Z1, so therefore the conjugate of that is -2 plus 3i. And that's it, that's all for the first part. Second part of part A then, plot and label Z, the conjugate of Z1 on the Argand diagram. So that's actually simple. Then once you, if you know how to find it, it's easy enough to plot it. So -2 plus 3i, remember you go across first and then up or down. So I'm going to go across to -2, which is there, and then I'm going to go up to 3i up there, so it'll be up there. So -2 plus 3i. And then it asked me to label there as well, so I've labeled it. That's the conjugate of that one on the diagram. Part B then, Z2 and Z3 are two other complex numbers. This is what they are, where I squared is equal to -1. So plot and label Z2 and Z3 on the Aragon diagram on the previous page. So simple enough again. Um, so Z2 is -5 plus 3i. So we go across to -5 and up to 3. So that will be Z2 then, up there. And Z3 is 4 minus 2i. So we have to go across to 4 and then down to -2i. So that'll be over here. So that'll be Z3. Um, that's all you have to do then for part B. Part C then, write Z2 minus Z3 in the form A plus BI. So what all they're asking us to do here really is to add the two of them together. Oh, and then it says hence find. And these two lines down beside Z2 minus Z3 over here, that means the modulus. Okay, so that's your root of A squared plus B squared. So that's how we find the modulus. Um, so let's go ahead and add them together first. So I'm going to take Z2, which is -5 plus 3i, and we're going to add, oh, sorry, it's subtract actually. So it's Z2 minus Z3. So we have to subtract then, and I'm going to put it into brackets here, Z3. So Z3 is 4 minus 2i. So we're really what happens here then, because we're subtracting it, you're subtracting 4 and you're subtracting -2i. So because you're subtracting -2i here, it'll turn it into positive because it's like it's minus minus 2i. So it'll be -5 plus 3i minus 4 plus 2i because it's minus minus. So therefore we just put the real parts and the imaginary parts together. So we have -5 minus 4 plus 3i plus 2i. Remember the sign in front stays with it. So minus 5 minus 4 will be minus 9, and 3i plus 2i will be 5i. So minus 9 plus 5i. And that's that found, okay? So we've written it in the form a plus bi. So now it's asking us to find the modulus of it. So like what I was saying, the modulus is a squared plus b squared, square root of a squared plus b squared. So a here will be minus 9. So we have to do minus 9 squared. And then we have to do 5 squared. So any minus number to be squared will become positive, or you can put it into your calculator. You can put all that into your calculator there if you want, and it'll give you your answer straight away. But it's going to be 81 plus 25. And then if we just add 81 and 25 together, we get 106, so root 106, and then that's our final answer really. I should have put them in the spaces here that's provided as well, so root 106 goes there, and the answer to the first part then was minus 9 plus 5i. You won't lose any marks if you don't put them in, but that's where we should put them anyway. So part D then, investigate if z3, which is 4 minus 2i, is a solution of the equation, and then it's z squared plus 2iz minus 7i equals 0. So that gives us a quadratic here. So all we have to do here really is sub in the complex number. So we're going to take this 4 minus 2i and we're going to put it in everywhere that there's a z, because we're seeing if it works for z. So we're trying to see if 4 minus 2i will work and make the equation right so that it will all equal 0 if you put 4 minus 2i in instead of z. So we've got z squared plus 2iz minus 7i equals 0. So everywhere I see a z, I'm going to put in 4 minus 2i instead. So 4 minus 2i squared plus 2i times, there's another z here then, so 4 minus 2i again. And I'll put brackets in around it, because if it's been multiplied by, I have to multiply it by the 4 and by the 2i, by the minus 2i. And then minus 7i is on the end here, and then equals 0. So all we have to do is just multiply everything out here and then see if it equals 0 at the end. So I've got a double brackets here, so 4 minus 2i squared, I can write that as 4 minus 2i, 4 minus 2i. So double brackets really, and I'm going to have to multiply them out in a second. I can already multiply these out here, so I can do 2i times 4, so that would be 8i, so plus 8i. And then 2i times by minus 2i, so 2i times minus 2i is minus 4i squared, minus 7i equals 0. So I'm going to keep, now what you can do with the I squared, anywhere you see an I squared in complex numbers, you can put in a minus 1 instead of it. I can do that here. I'm just going to multiply out these double brackets first. So there's different ways of doing this. Some people use a table, other people use these arrows up here like this to help them remember what to multiply. But you have to multiply everything by everything. So what you should get in the end is 16 minus 8i minus 8i plus 4i squared, because you've got minus 2i multiplied by minus 2i. So minus times minus gives us a plus. 2 times 2 is 4. And I times I is I squared. So, and then I'm just bringing down the rest of them. So plus 8i minus 4i squared minus 7i equals 0. Now, what you'll notice here is that you've actually got a plus 4i squared and you've got a minus 4i squared. So they'll just cancel each other out. So plus 4i squared minus 4i squared, that'll just be 0. So we don't have to worry about them anymore. So 16. Now I'm just going to put anything that's real together. Now, what you notice is I think 16 is the only real part that's left. There's no other part there that doesn't have an I on the end of it. Something I. So 16, we'll just leave 16 there. And then you've got minus 8i plus 8i. I could have cancelled those out as well, but I didn't. Oh, there was two minus 8i's actually. So minus 8i minus 8i plus 8i minus 7i. So those two will cancel out. So and equals 0. So I'm getting 16. And then minus 8i, take away 7i would be minus 15i equals 0. So what I'm getting here is 16 minus 15i equals 0. So I'm not really getting everything to cancel out. It's not simplifying down into 0 for me easily. I can't really go much any further than that because I can't do 16 take away 15 or something like that because 15 has the I obviously, so it's 15i. So it asked us at the start to investigate if it was a solution. So because it doesn't simplify down into 0, we can say that no, it's not. So your conclusion, what should have went in here, this part, was no. So no, it's not a solution. And that's question 1.